In this lesson, we're going to learn how to use the properties of logarithms to evaluate logarithmic expressions. Now, when I talk about the properties of logarithms, I'm talking about these things. These are the three main properties of logarithms. It turns out that if you have the log of a product, that's the same thing as the sum of the two separate logs. Similarly, if you have the log of a quotient, like a divided by c, that's the same thing as the log of a minus the log of c. And finally, if you have the log of something that has an exponent, that has the same value as multiplying by the exponent. So memorize these and let's see how we can use them. Alright, for this style of problem, we're given some facts. Log base 3 of 2 and the log base 3 of 5. We're given that information. Because remember, we will not be allowed to use our TI-30XS multiview, only a 4-function calculator. So these facts will come in handy. Focus on these numbers, 2 and 5. That's the key. As long as we can write everything in terms of 2 and 5, we'll be able to evaluate and find the answer. So when we look at problem number 1 and we see the 2 and the 5, that's just what we want. So looking at problem number 1, we see the log of 2 divided by 5. So remembering the properties, the log of a over c is the same thing as log of a minus the log of c. So the second rule is the one that we're about to use. So that means this should be the same thing as the log base 3 of 2 minus the log base 3 of 5. Okay? Division becomes subtraction. But we're given these two values. So the log base 3 of 2, that's our 0.631. And log base 3 of 5, that's 1.465. So you could do this in your 4-function calculator and get the answer. So that'll be negative 0.834 is the final answer. Alright, look at number 2. So when we look at number 2, we see this 10. I wonder how we could write that using a 2 and a 5. Oh, I know. 10 is 2 times 5. So let's do that. So this would be the same thing as log base 3 of 2 times 5. Okay, so looking back at the rules, that looks like this rule. Log of something times something is the same thing as the sum of the two logs separately. So multiplication will become addition as we separate them. So this would be the same thing as log base 3 of 2 plus the log base 3 of 5. So there's the 2 and the 5 like we had before. So this would be 0.631, and this is our 1.465. Again, you can add this in your 4-function calculator. So that is 2.096. Alright, by the way, if you have a pencil in your hand, put it down. You know better. If you're watching this video, it should be because you weren't sure how to do the problem, but you won't learn anything by copying off of me. So watch, learn how to do it, but then go back and do it yourself. No pencils. Alright, 125. So how can I write that using a 2 or a 5? 125. Well, looking at the chart, 125, that's 5 to the 3rd power. So let's use that, because that 5 is one of the things that we want. So 125, it's 5 to the third power. So this would be the same thing as log base 3 of 5 to the third power. So this reminds me of the third rule, this one. If you have the log of something with an exponent, that would be the same as if you put the exponent in the front. So if I do that, then this is going to be 3 log base 3 of 5. Alright, so that's 3 times, and log base 3 of 5 was 1.465. So 3 times 1.465. And again, you can just put that in your 4-function calculator. So that gives us 4.395. And that's the answer number 3. Alright, number 4, we've got the division, and we learned that when you had division, you could write that with subtraction, okay, using this second rule. So I'm going to break this part as a subtraction problem. So this would be the same thing as log base 3 of 4 minus log base 3 of 25. Now we need to get down to a 2 and a 5, and right now I have a 4 and a 25. So what am I going to do? You could probably guess it, because this 4 is the same thing as 2 squared. So there's the 2 that I wanted. And this 25 is the same thing as 5 squared. Okay, now we can use that third property about when you have an exponent, you can put it in the front. So if I put the 2 in the front of this one and this 2 in front of that one, then this is going to become 2 times log base 3 of 2. Okay, I just took this 2 and I put it in the front. Minus, and then I'll have 2 times the log base 3 of 5. Again, I'm just taking this and putting it in the front. Alright, now we can substitute those values that we know. So the log base 3 of 2, that was our 0.631. Okay, so this would be 0.631. Wait, well, we still have 2 times this. And then 2 times, alright, and the other one was 1.465. 1.465. Okay, so we can put this in our calculator. So that would be the same as 1.262 minus 2.93. And that equals negative 1.668. My class is coming in, so I have to stop this video now. They're very noisy. Alright, number 5. Now, keeping in mind that we're trying to get 2's and 5's. When I look at this 16, and I'm remembering that 16 is 2 to the 4th power. Yeah, 2 to the 4th power is 16. That sounds promising to me. So let's do that. So this would be the same thing as log base 3 of 2 to the 4th power. And then I'm remembering the third rule. The one where an exponent can come out in the front. So if I do that next, I win. Alright, if I take this 4, put it out front, then all of a sudden I have 4 times log base 3 of 2. Okay, and this is one of the ones that they gave us. Log base 3 of 2. Let's see, so that was what was that? The 0.631 apparently. In a four-function calculator, we get 2.524. By the way, don't round these. So that is going to be the answer to number 5. All right, number 6. All right, remember that we're trying to get 2's and 5's. Keep that in your mind. It's all about 2's and 5's. I'm lost. Oh yeah, here we go. Number 6. Okay, I'm thinking about exponents. Thinking about the powers that be. Because this would be the same thing as log base 3 of... you know what, first of all, let's go ahead and use the second rule, the one where division becomes subtraction. Let's go ahead and do that because I see this big fraction here. So that would make this log of 25 minus log base 3 of 16. So now 2's and 5's. It's all about 2's and 5's. Well, when I look at the 25, I can make a 5 out of that. All right, because 25 is 5 squared. 16, I can make a 2 out of that, because 16 is 2 to the 4th power. All right, remember we just did that. Now we could use the third rule where you put the power in the front. So I'm going to do that in both of these cases. All right, I can take this 2 and put it out front. I could take the 4 and put it out front. So if I do that, then I will have 2 times the log base 3 of 5 minus 4 times the log base 3 of 2. All right, we needed 2's and 5's, and we got just what we needed. So this is going to give us 2 times that decimal minus 4 times that decimal. Okay, and these are the the decimals that they gave us. So log base 3 of 5, that's your 1.465. And your log base 3 of 2, that's your 0.631. All right, you can evaluate this part in your four-function calculator. That turns out to be this. And then again, use your four-function calculator to subtract. So you get 0.406. So that is the answer to number 6. Okay, moving on. So for these next few problems, same idea, but we've got these new decimals. So this time it's all about 4's and 10's. So we need as many 4's and 10's as possible. Okay, well, number 7 is looking pretty easy then, because 40 can be written as log base 6 of, all right, we need 4's and 10's. How about this? 4 times 10. Beautiful. And now we can use that first rule where multiplication splits apart as addition. Okay, so that's going to give us log base 6 of 4 plus log base 6 of 10. And we have both of these decimals, so that's just 0.774 plus 1.285. All right, use your little bootleg calculator to find the final answer. It's 2.059. All right, there's number 7. Okay, here comes number 8. remember, we want 4s and 10s, 4s and 10s. Well, I'm looking at this 100, and I feel a 10 coming. So let's see, we have log base 6 of 1 over, now 100 can be written as 10 squared. Now, see how that's in the denominator? So I could go 1 over. 1 over 10 squared would be the same thing as 10 to the negative 2 power. Now I can use that second rule, the third rule, where the exponent comes in the front. So this is going to become negative 2 times log base 6 of 10. Okay, because we just went like this. Whoop. Okay, but we know this decimal. So that means I have negative 2. Alright, log base 6 of 10, that's your 1.285. If you multiply that by negative 2, you get negative 2.57. Alright, there are other ways to solve that problem, but that is the fastest. Alright, another way would have involved doing log base 6 of 1 minus log base 6 of 10 squared. Okay, but that would take you at least one extra step. Alright, anyway, number 9. Okay, now I'm thinking using the second rule to split this up right now. But let me remember what we're trying to get. 4s and 10s. See, there's already a 10 here. I can make this into a 4. Yeah. So let's go ahead and use that second rule. Division becomes subtraction. So this would be the same thing as log base 6 of 16 minus log base 6 of 10. Now remember, this log base 6 of 10, we already have a decimal for that. So we wanted 10s and 4s. So now this 16, I need to make a 4 out of that. So this would be log base 6 of course, 4 squared. Alright, this one is already the way I like it. Now I just need to move that 2 over, so you know, we can use the third rule, where if you have a power, you put it in front. So this is going to become 2 times the log base 6 of 4 minus the log base 6 of 10. Alright, now we know these decimals, people. So this is going to become 2 times, see, this is your 0.774, and this is your 1.285. Alright, bootleg calculator here. 2 times 0.774. Okay, so that gives you 1.548 minus 1.285. Back to the bootleg. And that's giving me 0.263. Alright, there's number 9. What else you got? Oh, wait a minute, where's number 10? Okay, number 10. Alright, remember we want 4s and 10s, if possible. But here I have this 5 and 2. I would recommend multiplying this fraction by 2 over 2, because that wouldn't really change anything. So this would be the same, alright, if I multiply both of these by 2. So this would be the same thing as log base 6 of 10 over 4. So look, we wanted 10s and 4s, now we have it. Let's use the second rule, where division becomes subtraction. So then this becomes log base 6 of 10 minus log base 6 of 4. These are both decimals that we have. This is the one that is 1.285, and this is the other one, 0.774. Bootleg it. 1.285 minus 0.774. So that gives me 0.511. And that is the answer number 10. Number 11. Alright, I actually had to sit there and think about this one. It took me about 60 seconds to ponder this one off camera. And this is what I came up with. I have a feeling there are several other ways of doing the problem other than what I'm about to say. But looking at this 25, and I'm thinking to myself, look, we're trying to get 4s and we're trying to get 10s. That's what we're shooting for, 4s and 10s. Now I'm looking at this 25 and I'm thinking, okay, I know that's 5 squared. Okay, but I wasn't really seeing how that was going to get me a 10 or a 4. And, you know, I could sit there and think about, things that multiply. So I could look at this as, I know this is 5 times 5 also. But again, I still wasn't seeing how am I going to get 4 or 10 out of this. So, okay, I had to really stretch my brain. And I was remembering the other problems that we did, like this one where I had fraction and then I made it bigger, you know, like I unreduced it. And I was asking myself, well, maybe I could do this that way. And especially trying to get a 4 in here or something. So I said to myself, okay, you know, this is like 25 over 1. Imagine that I multiplied both of these by 4. Okay, times 4 times 4. That would give me 100 over 4, right? Which makes sense. 100 divided by 4 is 25. So I'm liking that because I see the 4 that I wanted. I wanted a 4. And then even the 100, now I can see the 10 because 100 is 10 squared. So I think this is going to be a good strategy. I am going to go ahead and use the second rule right now, where division becomes subtraction once you split it apart. So this would be like log base 6 of 100 minus log base 6 of 4. Okay, so this part with the 4, that's ready to go. This, I will go ahead and rewrite it as 10 squared. And then this 2 can go in the front according to rule number 3. The C comes out front. Okay, so now we've got it. So this would be the same thing as 2 times the log of log base 6 of 10 minus the log base 6 of 4. Now we have the decimals for these, so we can do that easily. So this is 2 times 1.285 minus 0.774. Bootleg calculator here. Alright, so that's 2.57 minus 0.774. And that gives us 1.796. Okay, that's number 11. Alright, number 12. Can I see it immediately? Alright, we want 4s and we want 10s, remember? So I'm seeing the 16, I'm seeing the 0, and you know what I'm thinking? Alright, I'm thinking 16 times 10. Alright, 10 because I wanted a 10, and 16 because 16 is 4 squared. Now, if I use that first rule, multiplication splits apart as addition, then this will become, alright, log base 6 of 16 plus log base 6 of 10. Now this second one is done. It's exactly what we needed. We have the decimal for that. But this one, as I mentioned a moment ago, has to be written as 4 squared. And then the 2 comes out front. Okay. Now we have the decimals for these. So this is 2 times, this is your 0.774, and this is the other one, 1.285. Okay, bootleg calculator time. So this gives me 1.548 plus 1.285. So that is 2.833. That's it for the front side. Apparently there are problems in the back, thus the word over. See what that's all about. Okay, what's the invisible number, the invisible base here? Okay, that is an invisible base 10. So this is like asking 10 to the what power is equal to 100? And of course the answer to that question is 2. Okay, looking at this problem, this is like asking the question 125 to the what power is equal to 5. Now, if we want a big number to go to a smaller number, we really need to think about some sort of a root. Okay, but is it going to be a square root? No, there's your 125. The cube root of 125 is 5. Okay, so if I had a cube root, that would do it. Cube root is the same thing as the 1/3 power. Okay, so in this case, 1/3 power would do it. Okay, number 15. Now, my recommendation to you was temporarily ignore the 1. So at first, this would be asking the question 4 to what power is equal to 16? And the answer to that question, of course, is 2. 4 squared is 16. But because it wasn't really just 16, it was 1 over 16. Then what we really need is a negative 2, because that's what drops you down to the denominator. Okay, so there's 15. Now this one, this e is not the base. The base is invisible, but it is an invisible e. Okay, so this would be like asking the question, because it's like having log base e. So it's like asking the question, e, all right, focusing on the base here, the blue e to the what power is equal to e to the 7th power. Why did I make that a 7 a question mark? E to the what power equals e to the 7th power. Okay, so as you can see, I'm just setting it up the same way I did all of the other problems. base to the what power equals the other number. Okay, base to the what power equals the other number. But this time, since both of these are base e, then you can just use your common sense. Like this question mark and the 7, they have to be the same thing. So the question mark is 7. So the answer is 7. This one is asking the question 3 to what power is equal to 243? Well, look at the chart. All right, 3 to the 5th power is 243, which means this is a 5. Wait, I should be putting boxes around things, I guess. Yeah, okay. All right, 19. Again, I encourage you to ignore the 1 for a moment. So the question at first is 3 to what power is going to give me 9? All right, the answer to that question is 2, okay, because 3 squared is 9. But this was not really a 3. It was a 1/3. All right, because it's 1/3, instead of 2, it will take a -2. That would get the job done. All right, number 19. You should be asking yourself the question. 25 to the what power is equal to 125? All right, we learned how to solve these a long time ago. This one is slightly different than any of the other problems we've done so far, but the key is to rewrite these using the same base. It's going to be sort of like the way we did number 16. See, with both of the bases are the same, so we knew these exponents would be the same. 25 can be rewritten as 5 squared, right? So that's 5 squared. All right, now we still got this question mark. All right, so it's like 5 squared question mark. All right, 125 can be written as 5 and a power. So that means this is 125 is 5 to the 3rd power. Hello. Okay. So you can tell that off the chart. It's 5 to the 3rd power is 125. All right, now that the bases are the same, you know that these exponents have to be the same. Okay, so that means, just do this a little more over, that means 2 times question mark has to equal 3. So if I want to know what the question mark is, I need to divide both sides by 2. All right, so you can see this takes a little bit more work, but it pays off in the end because we find that that question mark has a value of 3/2. All right, last one. I have a 343 and a 49. I think this is going to have to be done the same way as number 19. Okay, instead of a question mark, I think I'm going to use an X because it's just easier to work with, or an N something. So anyway, you should be asking yourself the question, 343 to the what power is equal to 49? Okay, now you can't really do this directly though, because we don't have powers of 49 or anything. So that's why we're going to do it this way. So let's look for 343 and 49 on the same row of the chart. Okay, let's see. There's 343 and 49. These are both powers of 7. All right, so that's 7 squared and 7 to the 3rd power. They're both powers of 7. Okay, and like I said, I'm going to make this an N instead of a question mark, but same deal. Okay, so this is really 7 to the third power, and you've got your n there. Meanwhile, this is 7 squared. So now that the bases are the same, I know that these exponents must be the same. So that means that 3n must equal 2. Dividing by 3. So n is equal to 2/3. So bottom line, that is what we were looking for. That is the question mark. And that is it for this lesson. Okay, all right, that last part. The second page is really a review of some things that we learned on previous days. Peace out, people.